So for today's Data Guild meeting, we have Randy Zwitch and Zachary Blackwood from Streamlit talking to us about Streamlit for Geospatial. So take it away, guys.
Great, thanks for having us. Yeah, today what I'm going to do is just briefly talk about what Streamlit is, and then talk about how Streamlit and Folium can work together. And with me, I have my co-maintainer and senior data engineer at Streamlit/Snowflake, Zachary Blackwood. He did the majority, if not all, of the heavy lifting on the code side, and I really was just sort of the pretty face. So I've been at Streamlit for approximately 2 years at this point. Let me advance the slides. So, like I said, the first thing we're going to talk about right now is just the brief history of why Streamlit exists. What some of the main concepts are, why you might want to use Streamlit. Then, the majority of this I want to spend just like interactively working through some demos, showing you the code and things like that. And then finally, for the last 10 minutes, we can have, any questions and answers. Of course, please feel free to use the text chat as well. And then, I sent the slides to James already. So all of this is available on GitHub. So if you want to get these slides later, if you want to check out Streamlit Folium on GitHub, all of this information is available. So why does Streamlit even exist? So when you think about how we share information these days, certainly, or not these days, but in sort of data science, Jupyter Notebook was sort of the classic, huge advancement in sharing. We went from having Excel spreadsheets that we just sort of pass around, to potentially, using notebooks, printing them out, with NB Viewer and things like that. So now we can provide the code and the analyses to our stakeholders. But when you think about all the different types of apps that data scientists could use, we used to use Google Meet, and then I got used to Zoom, and now I need to. There you go. So when you think about what apps data scientists need, there's potentially dozens of different use cases, right? We have exploratory data analysis. We might be doing model monitoring. Maybe we're creating an executive dashboard. Maybe we're actually trying to create some sort of, formalized tool for people to use. And so when you go through, all the potential use cases for data apps, Jupyter Notebook is not necessarily, the greatest choice. Again, especially if you want to provide, a very web-like interface for users. And so, the reason that Streamlit was created was that building data apps tends to be slow and expensive. There's at least a couple of different workflows you might have. Here we talk about two of them. You might have explored your data in Jupyter Notebook. You can then, export the data into a Python script. And then, prior to Streamlit, you might have done something like, creating a Flask app. Django was probably too heavy-handed for it, but you could have used Django. Or, if you were, a decent engineer, you might have been able to do an HTML app, doing the JavaScript of it. The issue with this is what we would call the unmaintainability trap, right? If your background is in, data science or geospatial specifically, your focus wouldn't have been on app development. You would have been doing analysis. And so even if you could have created this app, you have a situation where it's not really your job responsibility. And so as you go through this, you may have created the app, but now you don't have the time to actually maintain it. And so you get a situation where people ask you for things, but you don't have the opportunity or you don't have the time to actually maintain it. The other workflow is kind of the classic large company situation where you actually have a tools team that's developing. This is your classic project manager collects requirements, a designer lays things out. the app gets coded up, in a proper front-end language. And now we're talking, a month later, 3 months later. And what happens when an executive says, hey, I'd actually like you to incorporate this feature? Well, the situation you run into is, those designers and engineers have moved on to the next project. Maybe you don't have the budget for it. You aren't the front-end designer, and so maybe you can't update it. And so you have a situation where things become stale. You can't really be flexible with the needs of a business. And so, whether you talk about this from a cost center cost, a time cost, the cost of building these apps is way too high. And so only a fraction of the tools that you actually might find useful actually get created. And so this is where Streamlit came in. We believe that Streamlit is the fastest and easiest way to create data apps. You can take a Python script, decorate it with a handful of Streamlit statements, and declaratively make the data app that you'd like. And you can see this animated GIF here is a self-driving car app. I believe this total app, so loading the model, doing all the data processing and the Streamlit calls, I think is something like 300 lines of Python total. And so if you've ever used TensorFlow and things like that, even loading a model and kind of dealing with that, is a significant number of lines. And so, to go from a model and actually display how it works, like I said, it's about 300 lines, and I think maybe 50 lines of Streamlit. And so, now what Streamlit allows us to do is to do our analysis in Python and then quickly turn that analysis into an interactive data app, which we can then share with non-technical users outside of our company, and so on. And it only is going to take somewhere from minutes to potentially hours, a half day to create this, as opposed to weeks or even months. And so the core tenets of Streamlit are really based on 3 principles. The first principle is embracing Python scripting. So if you think about how JavaScript works, if you've ever done JavaScript development or even PHP development or any of those sorts of things, you have a situation where, excuse me, a lot of the interactivity is done through callbacks. And callbacks can be sort of difficult to understand, excuse me, difficult to write. And so what Streamlit does is allow data scientists to use their normal workflow in terms of scripting. So as you can see in this slide, we have our normal import statements. And the first thing we want to do is just write something to the screen. And so, st.write, we're declaring that we want to see some text on the screen. St.write is one of our magic sort of commands. It understands Markdown, it understands LaTeX, it understands a handful of different things. And so, here we're already putting, a bolded large H1 title. We're putting in an italicized hello world. And it's as simple as that. So we declare it, the Python interpreter is running, it writes it to, the front end, and that's it. Now, of course, once we want to start putting data into our app, that df line, that's actually just pandas. That has nothing to do with Streamlit, right? We're going to read a CSV in. Excuse me for a second. Sorry about that. You read in your data frame, it now exists in your Python environment. And so this would have actually existed whether or not you had a Streamlit app. And so, to that end, if you already have a Python script, making a data app is just, perhaps 10 or 15% more work. It's not actually starting over from scratch. And then finally, we have the line chart function. This is a stylized example, of course. That's not exactly how it looks like on a Streamlit app, but you can declare, st.linechart past the data frame, and what Streamlit will do is infer what the X and Y axes are for your graph and automatically plot it. And so right away, this is very similar to how you might work in a Jupyter notebook or even the Spider IDE, where you have a handful of commands top down running, you incrementally add them, and you get the output displayed on your screen. The second way, the second tenet of how Streamlit was designed is treating widgets as variables. And so I talked about how callbacks can be awkward within JavaScript. You try to think about like, okay, well, if I click this button, this code happens, but did this happen before that? And is this available at this time? Frameworks like React and Vue and things have hopefully simplified that a little bit, but you still have the situation where for a data scientist or an engineer who might be thinking in a very serial order of code execution, it's sometimes hard to wrap your head around it. And so Streamlit does maintain that, how we think of sort of data scientists or data engineers, serialized code. And so what Streamlit does is processes code top to bottom. Every line gets run. Whenever an interaction happens on the screen, the interpreter actually goes back to the top. And so this is a little bit different than people are used to if you're used to using a Jupyter notebook, where you do that situation where you just sort of start in the middle maybe and you rerun a cell, and then you're going through this in kind of a checkpointed manner. One of the issues you run into with that, of course, is an uncertain state for the notebook. We've all sort of done that situation where you run something, you run it out of order, the cell numbering gets out of order in a notebook, and then you can't actually reproduce what you're doing, right? Of course, the solution to that is to run it top down. Streamlit only gives you this option through automatic reruns. And so when we're talking about treating widgets as variables, here, instead of having to think of callbacks as this weird piece of code that's over here and the button's over here and the button is talking to the callback, the situation you actually have is when you declare a Streamlit output widget, it returns the value back as a Python variable. And so in this example, if you see X, the slider is going from, what's that, 24 to 70, right? And as you're sliding this widget across, this value is being assigned to X. This variable X exists on the Python side. Okay, so if you want to use this data later in your app, you're writing Python statements just like you would any other thing. And so st.write, we're passing in a string, we put a comma, that value of X. We've now tied the value of the slider to the value of the output on the screen. But there's no sort of magic here. X exists before the st.write, and then you can use it that way. And so, as a second tenet, we've tried to make Streamlit, very linear in how you program to make it easier to understand, like I said, for data scientists and engineers. Of course, if you're going to rerun the code every time, it does imply a bit of a wasteful process, and that's where the third piece comes in. The third tenet of Streamlit was, when you're working with data, you're going to have a lot of, you're potentially going to have a large data set, you potentially have expensive computations, and you don't want to have to repeat those over time, right? And so that's the workflow I was talking about with Jupyter Notebook, where you might load the CSV at the top of your notebook, but then you actually just go back and you kind of rerun individual steps. Streamlit running top down each time, the way we handle this is through intelligent caching. And we do this using decorators in Python. So obviously, as the developer, you're going to understand the workflow you're trying to create. And so for situations where, like this one, where you have a data set that you're trying to read in, we're reading from an S3 bucket, we want to provide a select box where you can drop down and filter the data. Through caching, what we can say is, this data set should exist throughout the entire session of Streamlit. And so even though you're going to rerun from the top, don't continuously load this data set. What we do is we keep that in memory. We put the decorator on top of the function and say, keep this across reruns. And so what ends up happening is the first time you run your app, the data has to load. Of course, we don't have any way to manipulate physics or anything. You still have to load the data one time. But after that 5 seconds or 10 seconds happens, from then on, we're going to read it out of RAM. And so it can exist as if, essentially a free operation. It just skips right over that piece of code and keeps going down. And so those are the three main tenets of how Streamlit works to provide a much easier data app workflow for data scientists and data engineers. And so with that, I think it'll be a lot easier if I start showing how this works instead of talking about it. So let me go ahead and stop sharing the slides, but actually go and share my whole screen. Sorry, I have a Mac warning. I need to be able to share my screen. I need to quit and reopen this, so I'll be right back. Permissions are on. All right, my apologies. Let's see if I can share my whole screen now.
No worries at all.
Perfect. So when we talk about what a Streamlit app actually looks like, the code on the left, or excuse me, on the right-hand side of my screen shows, the beginnings of what a Streamlit app looks like. And so I'm using VS Code from Microsoft. You can do it any number of ways, but effectively, if we want to develop a Streamlit app, we can run an example like this, where you type Streamlit run Streamlit app.py, and then what ends up happening is a browser window will open and you will get your Streamlit app. And as we change things, we have the option to do live reloading. And so every time I hit save in this Streamlit app, we'll get a live reload. So just do something really trivial here. So you can see, up in here, it gives us the option of, you change the source file, what do you want to do? Do you want to rerun it one time or always? I always run always. Okay, and so, just as simple as that, we can start making changes to our app and, seeing them in real time. And so, this example here really highlights how the Streamlit Folium Streamlit component is intended to work. This is effectively interactive documentation. And if you've used Folium in the past, you will have seen an example like this. This isn't that impressive as far as things go, but we can see our code here. This code, right, is the same code that is here in my code editor. We import Streamlit, import the components to display it, import Folium. And so what Streamlit Folium is doing is, taking the API from Folium, which provides a lot of convenience in terms of creating leaflet maps. It takes the object that's being created on the Python side, and then through the st_folium function, we're reading out what the leaflet specification should be and creating it, in our data app. And so, this one's a really trivial thing. I live in Philadelphia, and so my example is the Liberty Bell. And you can just do things like this, okay? And so you would have this functionality if you were using Jupyter Notebook. I suppose you can also just export to plain HTML. And so, this itself really isn't that impressive. Where Streamlit Folium actually adds to the functionality is by making data bidirectional. And so what we can see here is if we go back to thinking about Folium, you can interact with the maps, you can do zooms and things, but Python itself doesn't have this sort of return mechanism. Things tend to be display only. And so it's very easy to create a map using Folium, but it's not really easy to get the data back when you're interacting with it. Of course, leaflets on the JavaScript side, you can develop this functionality to go back and forth, as much as you want. But if we're Python programmers, we don't necessarily have that ability. And that's what Streamlit Folium actually allows us to do. So if we take our example from before with the Liberty Bell, it doesn't look like there's a whole lot going on, but in fact, there is a whole data mechanism that's happening, a data passing mechanism, where we're getting back the potential of any different amount of information. And so at the most very basic, if you're thinking about doing a large scale geospatial application, you want to have the bounding box, right? If you're thinking about attaching this to something like OpenStreetMap or just PostGIS in general, you don't want to load a million data points into JavaScript. What you want to do is just load what's visible on the screen. And so in this case, when I move this around, you'll see the lat and long bounding box is changing. You also see the zoom down here. And so when I zoom in, zoom out, every time something's happening on the screen, we're getting information being passed back on the Python side. From the Python side, it's now available in Streamlit to pass back to the front end. And so you now have this bidirectional loop where you're actually touching things on the app. I just clicked, we return that exact point where I'm clicking on the map. Last object click is, your markers and things, these sort of change. And so, from a functionality standpoint, Streamlit Folium, really might not seem like a huge improvement, but effectively it does tend to allow a whole lot more functionality to Folium. And so, there's another way we can look at this. There's various plugins within Folium, which of course are wrappers around Leaflet. And so, the same thing here. If we have our example, all of this code right here, all of this code right here is just Folium code you might already have, existing somewhere. And once we start putting, okay, you can see that we're returning GeoJSON back to Python. We know that it's a polygon. We have its data points. We can draw a circle, and all these things become available on the Python side. And so now, as we want to make an interactive app, we can say, how many McDonald's are within 10 kilometers of my house, or what fits, how many national parks are inside this bounding box. All of those kind of point and polygon queries, your contains queries, you now have the ability to pass this information back to Python, do your filtering in GeoPandas, or as I mentioned before with PostGIS, passing these data points back into your queries, really gives you a live view into your data. And as I said, what's really great about this is it allows you to do larger data sets, allows you to actually tie your data or tie your application to a live data set where you can interactively query it. And so the better example of this, let me just close out of this example. is an app that Zachary created that uses the National Park Service API to display information about national parks. And so okay, so here we have, just a very simple, we're showing a map, we place the markers on it. If you're thinking about from a Python standpoint, how does this work? You can see, the writing that I have here is the same, writing that's on the screen. Like I mentioned, you just kind of declare markdown. It will publish it to the page. Here I'm using 2 columns. It's not really obvious yet. It will be in a second. But if you want to have a different layout in your app, you can do that using our columns and containers functions. And so, the first thing that we do is we have this function get data. And this goes back to what I was talking about before with intelligent caching. So we're connecting to the National Park Service API. What we want to be good citizens of sort of public infrastructure. And so with our function here, in this case, it's called st.experimental singleton. Experimental is just a temporary name that we have there. This is fully featured. It will get renamed as singleton, in the near future. But the idea here is we can ping the National Park Service API. We can get all of their data, that they provide, and we do this one time. So the singleton actually literally refers to doing this a single time, no matter how many sessions we have. And so if I publish this publicly, which it is provided, we'll provide the GitHub link a little bit later, but you can go and everybody is going to use the same reference point. This ends up being a memory efficient way to do it. Of course, it's time efficient as well because we only go to the internet one time to get the data. And so, we have our caching function here. We have some just basic Python, some data classes to define some points. Of course, we could have used GeoPandas. But, so now we have our Streamlit app here. So if it starts at line 61, all of the functionality you're about to see happens in 70 lines, including, proper spacing, comments, and so on. And so, what we have now is we have this map. You can see down here, parks visible 22. As we interact with this, okay, now there's 12 markers on the screen. We have the bounding boxes changing. Okay, but now, we can click on to one of the markers. We pop up, information. All of this is dynamically created. It's coming from the information that is coming from the National Park Service API. Here, I create a Folium pop-up. Folium supports Jinja templating. This isn't that complex, so I didn't do it. But ultimately, whatever is supported by Folium is theoretically supported by Streamlit Folium. And so any functionality that you have in a Jupyter notebook that you built in the past, or even potentially from the Folium documentation, you should be able to recreate within a Streamlit app. And so as I've clicked through here, we're dynamically, reading out the park's name. They provide their own descriptions. They provide an image URL. They provide a caption for each of these. So as I click on it, right, what we've done here is remove the need to understand how Leaflet works to be able to do this bi-directional piece. We've read the data in. No matter how people interact with your app, now they get a fully fluid approach. And again, this starts line 61 down to 131. So you're really, able to create this level of interactivity with maybe 70 total lines of code. And just to give it, a little bit of information or an understanding of what the National Park Service is returning. Okay, they're returning a lot of information back, right? This is one of the benefits of Python is, it's a very easy language to go through and parse various information. So this is just plain JSON data, but National Park Service is providing all this. All we're doing is outlining what the framework is to read all this data and make that dynamic within the app. And so hopefully, what I've shown here is that, even though Streamlit Folium itself is basically piggybacking off of Folium, Streamlit and Folium together really provide an easy, dynamic way to make visualizations that people can use without having the Python background. And that's really, I think, the big piece here is, Streamlit is trying to democratize the creation of data apps so that we can democratize data for all, right? This API is public. You do need a developer key, but you can sign up for a free developer key. You can now do citizen journalism. One of the big drivers of Streamlit growth was COVID dashboards. Those Streamlit became a public open source project in October 2019. Of course, around March 2020, at least in the United States, COVID really started to become thought of as a worldwide pandemic, and hundreds, probably thousands of COVID dashboards have been created. And so this is really the vision that Streamlit has tried to create, and that Zachary and I have tried to continue with Streamlit Folium. With that, I actually finished a little earlier than I expected, but I'd love to hear any questions. In fact, actually, I have a few more slides. Let me. So the last thing I will finish with, even though I'm finishing a lot earlier than I expected, was volunteers are greatly appreciated. So as I'm sure all of you understand, open source projects are really only as successful as the group of people who are actively contributing to them. While Zachary and I are both Streamlit employees, or in this case, Snowflake employees, this project is a community open source project, which is to say we can work on it at work, but this is not formally part of the company strategy in any way. I was interested in it originally. Community members were trying to understand how they could use Folium. And so, this is an MIT licensed project. It is freeware. This is not, gated in any way. We don't get paid other than, our normal day jobs. And so, any help, is really appreciated. And so I've just outlined a couple of ways, that I think Spark Geo specifically, or geospatial people specifically, can contribute. And the first thing is, improving the examples. So as I mentioned, if you go to the GitHub repo, all the code that I showed today is part of that repo. It is deployed on Streamlit Cloud. And so, the first thing is, just make better examples, right? The first thing of my trivial example showing the Liberty Bell, of course, demonstrates the function, but, making an amazing example would be, something that I'd love for the geospatial community at large to do. Another thing could be, just test the Folium documentation examples. I know Folium demonstrates how to use Vega Light inline to, have pop-up charts and things. We're still kind of figuring out all the new functionality, that is possible. And so, going through those examples, trying to do different tile servers, just anything that, if you guys build something awesome, let us know what the problems are, what rough edges you have. Someone in our issue tracker was trying to use Google Earth Engine, right, Gmaps, and he's having a little bit of difficulty. Like, that's the best thing ever, is, you know, is when people actually provide, you know, use cases that don't work, because, you know, we can only fix things that we know. When I talk about fix things, I gave Zachary a handful of bug fixes this morning, and he was able to, you know, get them done before this talk. You know, that's the only way that any open source project is better. And so, you know, if you'd like to get involved in something like this, you know, we would appreciate any sort of, you know, participation that you have, whether it's building something awesome. If you happen to know JavaScript, okay, there's other plugins that Folium supports that we don't yet support. And so the way we've set up the bidirectional data flow right now is effectively you just need to add another key to the JSON object, and it's going to get passed back. And so you don't need to understand how the Streamlit portion works. If you understand JavaScript, just going into that TypeScript file, you know, adding in that plugin and then writing that new field, it will automatically get, you know, into the Streamlit portion of the code. And so especially if you know JavaScript, and can help us add more Folium plugins, you know, that would be a huge help. I don't know JavaScript, so I am relying on Zachary for pretty much all of this. And so any help there. And of course, if you either can't or don't want to participate like that, you know, the best thing that of course you can do is just telling other people, right? If you're running into people at geospatial conferences, you know, people are talking about, oh, I wish I was able to do this. You know, just letting them know that there's a Folium connector for Streamlit will be tremendously helpful. You know, just getting the word out is kind of the way, you know, open source flourishes. And so that's my last pitch. If you want, oops, so there you go, there's the issue tracker. I lost my, there you go. So where can you get more information about Streamlit? Of course, you know, from base perspective, I would assume that everyone on this call probably has more Folium experience than they do Streamlit experience. And so if you want to learn more about all the widgets and everything that's possible within Streamlit, the first place I would go is our documentation. So docs.streamlit.io has, you know, not only, you know, every doc string, there should be an example for every function. There is potentially a video, you know, that takes a minute or two to explain sort of the subtleties behind this. So, you know, our documentation is obviously, you know, is always a great place to go. If you have specific questions or you want to show off things that you've done with Streamlit Folium, our discussion forum has a section called Show the Community. This is a great place to just sort of demonstrate any, you know, apps that you've made. Works really well if you deploy it on Streamlit Cloud, which is free for our community tier. You know, this is a great way to share information, you know, collaborate with other people. And of course, if you have questions, you know, the using Streamlit section or the Streamlit Cloud section, or even the deploying Streamlit section, if you want to deploy this privately on your own cloud or, you know, internal infrastructure, any of those sorts of questions, you know, support type things, you know, that's a great place to go. And then finally, we don't have a ton of geospatial content yet, but our blog is another great place to see what other people in the community are doing with Streamlit. I am going to write a blog post at some point about Streamlit Folium so that we have a better place to point people. If you have a case study, you know, if there's something that, you know, you're doing for public good and you'd like to feature it, you know, we'd be happy to collaborate with you to put that on our blog as well. And with that, I think that's about it. We have about 10 minutes if there's any questions.
Great, thanks, Randy. That was awesome. Yeah, does anyone have any questions? I have some, but as per usual, I'll hold off and give everyone else a chance. Go for it, Dustin.
You're muted, Dustin.
Can't hear you, Dustin. Oh, okay. Anyone else while Dustin reconnects? I'll start us off with one then. How do you serialize Python objects? Like I've used Dash in the past, and one of the issues there was whenever you wanted to display a somewhat heavy Python object like a NumPy array, it would just slow the whole web page down. How do you guys handle that kind of thing?
Sure, there's a couple parts to that question. First, I want to say it's like version 0.85, but that version is important. We're on kind of version 1.9 right now, but we moved to using Apache Arrow for our data serialization. And so the benefits of this are that you're passing binary blobs between Python and JavaScript, the front end. And so Apache Arrow is specifically designed for this use case of passing large amounts of data between two systems. And so from a serialization perspective, we try and use Arrow as much as possible. And that incrementally gave us something like a 10 to 13 times speed up over the way we were doing it. Of course, there's no, as I mentioned before, we can't bend physics, right? And so if you try and send 10 gigabytes of data to the browser, it doesn't matter what project you use, it's not going to work properly. Of course, what we've tried to design for here with Streamlit Folium is that bounding box idea that if passing 100,000 points or 200,000 points or something might not be that big of a deal, and as long as your back end, whether it's Postgres or some other data storage mechanism is fast enough to return it, right? You can incrementally make that much larger of a project. Now, in terms of how we serialize normal objects, we use Pickle almost exclusively. And so when you're creating the singleton objects, when you're using stcache, stmemo, those use Pickle so that you can read arbitrary Python. Those objects most likely or all the time aren't getting past the front end. And so when you're doing Pickle serialization, it's just that you're trying to save your data set or some expensive computation on the Python side.
Okay, great. I think that really answered my question comprehensively. Dustin, I think you're back now. So
yeah. Thanks for the talk. I actually got two questions, and one is on deployment options. I mean, there's obviously the cloud option. If let's say I created an app and I want to deploy it out, would it go behind a kind of an Nginx and gUnicorn kind of idea? Is that generally the way to deploy?
So that's the first question, or is that both?
That's the first question.
Okay, so the deployment, as I mentioned, Streamlit Cloud was our commercialization strategy prior to being acquired. Now that enterprise piece will move to Snowflake. I'm not going to talk any more about that now. One, because I want to keep this an open source talk. Two, because it's not developed yet. On the community side, we still do have the free tier so people can share their work, and so you can deploy it through Streamlit Cloud. Now, in the case of this is an actual business critical application, it's sensitive information, things of that nature. You can run it on any of the clouds, and so AWS, GCP, and so on. If you want to have HTTPS support, if you want to have a custom URL support, you can run Streamlit itself and then have a reverse proxy from Nginx or Apache. That way you can have your domain, you can have your security in that sense. Streamlit itself is built on the Tornado project, and so it itself is a web server. So if you don't need all that functionality, you don't have to go through the setup piece. You can actually just do Streamlit run, have it as a cron script or some sort of monitoring to make sure it's always running. And it itself is a web server.
Okay. And that probably answers my second question anyhow. I was curious about integration. Like, does Streamlit need to be a server on its own, or can it be used as a library within an existing application?
Yeah, so Streamlit itself is its own project and server. And so occasionally have people say like, hey, can I import Streamlit widgets into a notebook, or can I do this from Dash or something? And that's not how we were focusing on it. It's really meant as a standalone project in the same way the Flask might be. I have seen some people start to make things work. So I'm fairly certain I've seen Django authentication, but within Streamlit. Obviously, whatever is possible with computers, will be possible here. But Streamlit is meant to be a standalone piece. It's meant to be the presentation layer, and then of course anything that exists in the Python ecosystem right now, as long as you can represent an HTML in some way, can be displayed in Streamlit. And then when you think about things like databases, does Streamlit support a database? That's actually the wrong framing of the question. Anything that can be done in Python can already be done in Streamlit. And so, if the database connector already exists, right, you'll read that data into a pandas data frame, and then that's where Streamlit starts. We take a pandas data frame, you can do anything you want, you can display it however you want. And so we do have, I think, a pretty good integration story. We're not trying to exclude people. Technically, Plotly would have been one of our competitors. We support Plotly charts directly. We support Bokeh. We support Altair, PyDeck. Any of these sorts of projects. We've really been trying to steal a phrase from someone else in the open source community. Building bridges. We're trying to build bridges. We were trying to do the best thing that we could as an execution model, and then bring all the PyData projects together.
Cool. Thank you.
You already answered a couple of my questions there. I was going to ask about Jupyter integration, but you answered that one already. So anyone else with some questions?
I have some more comments about Jupyter. Maybe I'll answer that. So some people have tried this. People, what happens if I have Jupyter Lab and I want to deploy a Streamlit app? While we don't directly support this, it is possible to do things like that. I mean, you can use Jupyter Magics to export to a Python script inside of a cell. And so it is kind of possible. It's possible to use Google Colab with tools like ngrok if you want to use their free. So there's ways to do it. If you have a question about like, can I hack these two things together? Our forum is a great place for it. And specifically, we have a community developed deployment guide that tries to go through all the permutations. If someone knows how to do a Windows server, or can I do this off a Raspberry Pi, or I've seen people try and use RAID backups. What are those things called? The home, like a home cloud server that has like its own little processor in it. Like how do I run it off of like a, people have tried all sorts of weird things. The best place to go if you have a question like that is our forum with that deployment guide.
Okay, great. Definitely be looking into that. Any more questions for Randy? I just want to mention how nice it is that you guys support the other plotting packages. Like a lot of the cool geospatial stuff is happening with like Cola views and Bokeh at the moment. So it's neat that you can integrate that with your product as well.
Yeah, like I said, as you guys try and build cool things, if it doesn't work, please let us know. We can, I mean, obviously, the name of this package is Streamlit Folium, but of course, we have, the ears of our product and engineering teams. And so if it's something, that could be added to Streamlit Core, we've certainly, talked a lot about GeoPandas integration. We don't know how we're going to do it, but, please let us know. This talk today is as much, about Streamlit Folium as it is to, talk with the geospatial community. And so find a way to let us know, and, we'll see if we can support it.
Awesome. Great. Well, if there's no more questions, then I guess I can just stop recording and we can leave it there.
Well, great. Thanks so much for inviting us. you know, I love doing these types of talks, talking to the community. Again, I'd love to see what you guys build. And even if you don't build something, tell somebody else, and we'll see you down the road somewhere.